Hey everyone, what is going on? I'm the Savage Coder, and this is episode 8 on Scope. Not the stuff you put in your nasty mouth in the morning, the other kind of scope, programming scope. Let's say I got something that's private to me. I can think about it, I can change my mind about it, I can change it, but you still don't know what it is, because it's private. But if I tell you my name is Savage Coder, you could be like, hey, I know his name because that's public information. He told it to me, and even though he says that's his name, I'm going to just think of him as yo. What's up, yo, right? So it doesn't matter. You know it, I know it. We can share that information, but what's private is private. And that's kind of what we're talking about, and we're going to get into it right now. All right, scope. So what is the Microsoft definition of scope? It defines the lifetime of an object or variable and the boundaries of where it's visible to other code. Well, that clears it all up for me. I'll see you later, folks. No. Let's talk about what it actually is. So in this example, I have a class called foo. This class has three parts to it, three main parts. The first is the actual class, and it's defined as a public class. It has in it a private field that we named _API, and it's very common for private fields to start with an underscore for the name. The name is irrelevant. That can be anything. It's just a variable. The data type for our _API field is another class called API connection, and that's probably defined somewhere else. We don't have to know what it is. We just know that API is of type API connection. The next thing we have is our public constructor. A constructor is something that every class has. You can tell it's a constructor because it has the scope of public, and then the name is the same name as the class. It doesn't have a return type in its method, like this public getUser method has a return type of user. Notice there's no void, there's no nothing here. Public foo being the same name as class foo tells us that it's a constructor. So what's special about a constructor? Constructors will run when this object gets created. We can see that with our private API connection from outside of this class when we create an instance of foo with var some variable equals new foo. It's that line of code we'll call the constructor, the same way that new API connection right here will call the constructor inside API connection. Now, you don't have to include a constructor in C#. Every class has a default empty constructor. So even if I didn't have public foo here, because it's public, you could still new it up, and it would still call the default constructor. In our case here, what we're saying is when a class foo is created as an object, as a new object, that we also want to create a new API connection object and assign it to our private field so that we can use it later. And then we have a method down here called getUser that takes a username in, and it uses the API and gets that user from a database by username. So we pass it in a username, and it gives us back some dbuser. Looking at the scope, we can see that foo is public, which means that we can new it up outside of this class when we want to use a class foo, and we would do that this way. Foo, data type, my foo, variable name, equals a new foo. We also could say var my foo equals new foo. We actually can't make class foo private because then we wouldn't be able to use it for anything, so what would be the point of that? Okay, so let's look at the scope of this private variable. You would think that because it's marked private that we wouldn't be able to use it. But what private in this context means is the variable _API is visible everywhere inside the curly braces where it's defined. In this case, the whole class foo. We can use it inside anything that's created at the same level. So underscore API, we can use that inside our constructor. Underscore API down here, we can use inside getUser because it's defined all the way at the top. It's private to this class though. So if we went outside of this class and created a var myFoo equals new foo, we could then not say myFoo dot underscore API. We cannot access underscore API from outside of the foo class. Even if we create one from outside, because the class is public, we can only get to the constructor and the getUser method because they are marked public. But private actually hides this functionality to only be usable by the class foo. Another thing we can't do is reuse the same variable name. We can't come down inside getUser and create a new variable called underscore API, which is of data type string. It doesn't matter what data type we use here, even if we tried to make it an API connection, since we defined our variable up here at the top, it's still considered in scope inside this getUser method. So while we can use underscore API because it can see it from up here, we can't make a duplicate variable with the same name inside here because it would conflict with the one we defined at the top. So what happens when we are inside of curly braces when we define things? So here's another class foo. This time it's got a string called underscore username. And in our constructor, we're hard coding Savage Coder as the value of username. It's a string, so we're happy. Then inside the constructor, we're calling a method down here called getUser, and we're passing it underscore username. In this case, underscore username comes in and is represented by this parameter username without the underscore and without the capital N. This is considered a new variable that's defined at the level of this method. So the value that gets passed in here is going to be Savage Coder, but we refer to that value of Savage Coder inside getUser with the variable username that's passed in. Here we call underscore API.getUser from DB, and we pass it username, which would have the value Savage Coder. What we get back here is var user, and then we return the user object that we got from the database back to the caller. Here's the caller right here. We called into this method, and we return a user back that gets assigned to this variable. So these are like your input here and your output here. And then you receive your input on your method here, and you return your output back to the caller. So the thing that's unique here is, notice this variable is user, and this variable is the same exact name user. However, in this case, they are not the same variable. The reason is, this variable is declared inside the constructor. So its whole lifetime is from this opening curly brace to this closing curly brace. And it has nothing to do with this var user that is created as a result of a method call, because this var user only lives inside this curly brace and this closing curly brace. So since they're defined in their own little world, they are local to where they are defined, and C# is completely fine letting you reuse this name. Now, this could be really confusing to another developer that might come in after you, so I kind of recommend not to use names over again, but sometimes it's just the best thing you can do depending on the circumstance. But for the most part, I would say try not to reuse the name user. Maybe this could be initial user, or this could be called var user from DB or DB user, or just something that tells what it's holding. But as far as C# is concerned, this is completely valid. And you can think about it as the most nested scope always takes precedent. So we just keep in mind that if we declare something inside curly braces, it has the scope of the opening and closing curly braces. So this private has the class foo scope. This var user has the constructor foo scope, and this var user has get user scope. And it always works that way. So let's see how this looks in practice. So here we are inside our class program main, and we create a new user object from our foo class. So I'm saying var user equals new foo. No problem. We create foo, which assigns Savage Coder to username. It calls get user, passing in that username, and same code like we had before. So what we can't do here is we cannot do user._username equals Savage. And the reason is underscore username in this example is private. So the underscore username would not be available outside. And that's one of the reasons that we put underscore here. If we're using it later in code, we don't get confused that it should be public. And if we ever see code like this, user._username, it kind of tells us that we probably shouldn't be accessing or trying to access a variable that looks like it's private. The other thing that you can't do is you can't create another user variable because we named our new foo user, which is kind of a confusing name, but we created a new foo user, then we can't say var user equals something because this user and this user are in the same scope. So rather than do that, we could do something like var usr equal user.getUser and pass in Savage. For best practice purposes, I would recommend that this be var foo in lowercase equal new uppercase foo. And that way you can type var user equal foo.getUser. And then it's nice and clear because your names make sense. So try not to mess up your variable names and make them meaningful when you create them. All right, let's jump into code and see how it works. Today we're going to be talking about scopes in the context of a login page. So imagine we had a web application or a mobile application or a desktop application that had a login screen where you had to put in your email and a password. And we'll simulate some of that stuff, but we'll get to understand why we make things public and private as we build this login logic behind the scenes. And then in a couple episodes, we'll go ahead and create a user interface that attaches and uses this stuff. So let's take a look at Visual Studio. As usual, I am going to speed through this part. We'll call this noblecause.login. All right, so this main method in our program CS will control all of our logic, but let's go ahead and create our classes. So this time I'm going to right-click on the project and do add. Make sure you don't right-click on solution because that would just be for adding other types of projects to the solution. We want to right-click our project, add, and this time I want to put new folder. We'll call this folder models. And inside models, I'm going to add a class, and we'll call that class a login user. I'll make this class public. And for now, I'm just going to add a public string username and a public string password. I'm going to right-click these usings up here and select on our right-click menu, remove and sort usings, or you can do Control-R, Control-G, just to clean those up so that we don't have extra stuff we're looking at. The next episode, we're going to talk about namespaces, so we'll cover the usings and namespaces next. All right, so we have our login user that I think we can use for now. I'm going to create another folder, and we'll call this folder services. So the services are things that are going to act upon our models. So I'll make a class inside services, and we'll call this the login service. Now, the login service is just a public class. And for now, we're just going to have one method. And we'll make it public. And we'll have it return a Boolean, true or false. And I would normally call this something like login user, but because we called our model login user, I don't want this to be confusing. So I'm going to name this validate user, and validate user will take a string of, let's switch that to email and password. So let's go back to our login user and change that to email. Back in models. Okay, so back in our login service, we're going to validate user. We're going to pass in an email and a password. We'll create a variable called isValid, and we'll call another method called, oops, not that, check user is valid. And we'll pass that the email and the password. I know it's a little convoluted that we're calling a method that just calls another method, but there's a reason I'm doing this, and it'll make more sense in a minute. So it's telling me there's two problems here. The first one with validate user is that I told it I'm going to return a Boolean, and I'm not returning anything. So if I hovered that, it basically says not all code paths return a value. And this one is complaining because I told it to call check user is valid, and it does not exist. So we're going to create that now. Public bool check user is valid, and it will also take in a string email and a string password. And we're just gonna say if the password equals 123, then we're gonna return true. Otherwise, we're going to return false. And if any of you are any experienced developers, you're cringing right now, and I will fix that because it's actually bugging me a lot right now. But I want to keep things very simple and straightforward, so let's stick with what we got. And here we are going to then return is valid. So there's our service. If we create a service and we call the service.validateUser and pass it an email and password, this method will call this method, passing in the same email and password. We have a ridiculous check here that just makes sure the password is 123 and says, yep, that user is good. Normally this would call out to a database, and it would do some encryption, and it would check passwords or do some OAuth or whatever it's going to do. For our purposes, we're going to keep it simple, just to illustrate more about our scope. All right, so now let's go into our program CS. And we'll go ahead and crank up the size here. And I'm going to create a new service. So I'm going to call it var login service equals new login service. Now, because my login service is in a different namespace because I put it in folders, you can see when I created login service, it changed the namespace to login.services. And because program CS is only in noblecause.login, not login.services, it can't see that. So, and we'll go over this in the next episode, but I have to put in here using noblecause.login.services. And now that I've told it where to look, it can find login service. And then in here, login service, I can validate user. Now I have to pass in a login and an email and a password. So let's create our, we'll just call it user equals new login user. And again, it can't see login user because that's in the models folder, which put it in the noble cause login models. So an easy way to add this using, I could type it out the way I did that the first time, but if you just hover the red line, it says the typer namespace could not be found. Well, if you see this little light bulb that pops up here, or sometimes if you just click in, it'll pop up over here on the left. Same light bulb. If you click that little down arrow, that was a little tricky, you can see that it's saying, well, if you add using login.models, then everything will be okay. And it shows you over here what it's going to look like after it adds that code. Well, that's exactly what I want. I'm going to select that. It added the models here. And so now it's happy here. And user.email is going to equal oops, helps if I, sorry about the quotes, been doing a lot of JavaScript. Okay, and so we have our email, and user dot password is, we'll start it off with a valid user, which was, it's going to check for that password equal 123. And now we can just pass in the user.email, comma, user.password. And that's because validate user takes a string email and a string password. And then that validate user method, remember it returns a bool. If we go back and look, when we call validate user, it checks if it's valid and it returns is valid as a Boolean. So we can consume that Boolean in a variable, and we'll just call that is valid. Remember, anything that we're creating here is only valid in the scope here. So even if we used is valid inside here somewhere, which we did inside there, that variable only lives in this scope. So we're fine using that name. And then I'm going to console.writeLine. We'll use our string interpolation and say that user is, and then we'll put is valid. Well, that's going to say, that's going to put true or false. So the user is valid, and it'll say true or false. So let's run that. So it says the user is valid, true. And if we change this to anything but 1, 2, 3, it should say false, and we'll step through it to give you an example. False, good. All right, so I'm going to put a breakpoint here on line 11 just by clicking in this little gutter, and I'm going to click the run button. And the first thing it's going to do is create a new login service, which calls the login service constructor, which it doesn't have one, but every class has a default constructor. Now we're going to call the login user constructor and create one of those. It also does not have one defined, but uses the default. And now we're going to step in and we're going to assign the email field to a variable, and a password is going to get assigned. And if we hover email, you can see it has Savage Coder. It's kind of small, but, and 456 was assigned. And so I can pass those values. Now, if I step in, you'll note that the email and password have the values that we passed in. It's now going to call check user is valid. and it's going to compare password with 123 since it's 456. That is not true, so it goes into the else, returns false, and then validate user then returns false because we got our false back from check user is valid, and then we write out the user is valid false. Okay. There's a couple of things that are wrong here. I want to build in some security here. One of the things that I can do right now is I can call login service and I can just say check user is valid. I can call that method. Now, I don't know what that method's doing, but the fact that I can get to it, if that's the inner workings of my login service, in this example, it's not that critical because they do the same thing. But let's say that validate user called some things like return the whole user object with all the user's information. I wouldn't want users of my login service to be able to call those inner workings. But here you can see it has no problem. If I passed it in 2 strings, it's fine. It doesn't care. But let's say I don't want people using the login service to be able to get to that because it returns what I consider kind of protected data. So I'm going to go into my login service and I'm going to change this from public to private. So what that does is now if I try that line, it won't let me because it says that it's inaccessible due to its protection level. Because it's private, I can't call it from out here. So I can still use the service. I can still call validate user because it's public, but what it does is nobody else's business. So I like the idea that that's private. Another thing that I can do is maybe I want to make sure that when you assign an email address to the email field here that it has an @ sign in it. Now there's some better checks we could do for email addresses, but to keep it simple, I could just look to see if there's an @ sign in the string that gets assigned. But if you look at the model, there's really nothing I can do here about that. We're publicly exposing the email field, and so you can assign anything you want to it. So one of the things I can do is I can make this private. So now only the login user class has access to email. I'll get an error from outside because I can no longer assign directly to that. And I'm going to rename this underscore email. I explain why I use underscores for private fields in the previous video. Card! All right, then I'm going to make a public accessor for my email address. And I'll call that email. And now I can kind of make code that runs when you set email and when you retrieve email from the login user class. So when you're getting, right now I can say return underscore email. And when you're going to set the value, for my setter, I'm going to assign email is equal to, and there's a built-in variable inside properties called value. So when I say from the outside dot email equals something, it's going to call the setter because I'm setting this value into email. But when I use email here where I'm not using an equal sign, I'm really just passing it in, that will call the getter. And that's how get set works. So right now I set anything I want here in email. But what I can do is I can add a check in there and say if the value that's coming in contains an @ sign, then set that. And for the purposes of example here, you would never do anything like this in code normally. I can say email equals no email set. And so For password, I don't have any rules like this. I might have some password rules, but for password, I'm going to just do what we call an auto property, which we just tell it, use your default get and your default set, and pretend there's a backing field here, just like this used, but expose yourself as a public property the same way that this exposes a public property. The difference between these two syntaxes is that because I have a private backing field here, I can do things like this if, where with password I really can't. There are some other things you can do in here. I can put private set, which would mean I can only set the password from inside this login user, and it's private outside. Which won't work for us because we're actually setting our password here. So that won't let that work. So we'll get rid of that. So now, for email, okay, what I'm going to do is before I execute this email line of code, I'm going to go into my model. And I'm going to put a breakpoint on the getter and on the setter. And so now if I step in, you see my breakpoint is on my setter, and the value that I'm passing in does have an @ sign. So it will go in there and set the value of email to the email address. And the password just sets the password. And now when I go to validate user and I try to access the email, that's just telling me it wanted to step over the property by default, but I have a breakpoint in here, so it will still always stop at a breakpoint. So now it goes and it reads _email, which I previously set to my email address, and it returns that value out so that we can see the email. And the password is the password. So that works good. And you see that it runs normally. What else can we do to improve this? Well, a couple things. First, we're going to go in and we're going to clean up this login service. I'm going to right click my usings and remove and sort usings. That cleans the top of that file up. The next thing I'm going to do is, rather than creating a variable here and setting it to check user is valid, so that's going to come back true or false, and then I'm returning that variable. I'm not really using the variable for anything between here and here. So there's no reason that I can't just return the result. So I can actually get rid of this and get rid of this and just tell it return that value. It does the same thing, but it saves me the creation of a variable. Same thing down here. I'm saying if password equal 123 return true, else return false. Is that not the same thing as saying return password equal 123? Right? If password equals 123, that's going to be true, so it would return true, and if it's not equal, it will return false. So I can replace this refactored code and save. I can turn 8 lines into 1. Our login user looks good, and our program CS we could make shorter with some separate syntax here. One thing we can do is we can assign these two variables in the creation of the login user. And the way we do that is we replace these parens with curly braces. And in here, we just name the two properties that we want. So I can just put that in here. And then we separate them by commas inside here because of the curly brace syntax. And that, so now I can get rid of those 2 lines. And all it saves me is user dot. I don't have to type those. So that's nice. And the other thing we could do if we wanted was we could just pass in user here instead of the two values. And we would have to change the service so that it takes a user. So instead of validate user taking in an email and a password, it would take in a login user called user, I guess. And it's complaining about the namespace, so I can hover and do my little light bulb and bring that namespace in here. And then I can replace this with user.email, comma, user.password. And that way we're passing in our login user, and then we're just accessing the properties to satisfy the requirements here. So that cleans a lot of that up. And the user is valid false. The other thing we could do is we could let the user pass in the email and password values. So I'm just going to make a var called is done, which is false, and we'll say while not is done, which will just keep repeating everything in between these curly braces until is done is true. And we will console.writeLine email and I'm going to duplicate that for password, and we will console.readLine. Let's grab our go back to our first syntax of creating a new login user called user, and then we will put here user dot email is equal to whatever the user types in at the prompt, and I'll copy that and make that user dot password. And so then they'll enter their password. So after the user enters their password, we no longer need this code because we're going to get that from the live user. Then we can check if it's valid, passing in that user. And this is complaining because we have is valid here and is valid here. And since this one is at the outer scope between these two curlies, it says this one's still visible inside here. But we don't need this one anymore. We're replacing that logic. And so now this would work forever. There should be a way to exit. So we can just check that if you put in if user dot password equals -1, and password's a string, so I had to put it in quotes, and readLine returns a string anyway, so it would match. So if password equals -1, then we'll set is done equal to true. And that way when it loops around in the while, it's going to say oh, it is not done, no it is done, and it'll exit. And so if we run that, we should be able to enter logins and passwords. Enter email. Let's test our if logic in our setter here. I'm just going to put a J. And then the password is going to be 123. Oh, we never printed out. Let's do the user is, and we'll put user dot email. There. So now we'll see the email. So remember, if I just put a J in here, it doesn't have an @ sign, so that other logic is gonna. So here it'll say the user is no email set, even though I typed a J. But if I put j@j.com and then 456 will fail. So it now knows the user is, and it'll just keep going there forever until I think we did password. Yeah, password. So I can put whatever I want for email, -1 for password, and it exits the loop. And hopefully that gave you a cool idea of scope, how to use things, how to make things public and private, why we want to make things public and private. Don't worry too much about all the refactorings that I did. That stuff comes with time. I just wanted to expose you to some of the things that I look out for on how to simplify code, but still keep it almost human readable, understandable. But don't worry if you don't see those things for a while. There's nothing wrong with doing it the other way. It's just a little bit more efficient this way. And as always, please practice all of this stuff. Next time, we're going to talk about namespaces, and then we're going to get into some actual applications and putting all this stuff to real world use. Finally, I know some of this stuff has been a little boring, but hang in there with me. You're almost a programmer, and we're going to go through everything you need to know step by step, inch by inch, one by one. I'm just blabbering now. So I will see you where? Online.